I'm Taylor Toby. I'm an OpenSciEd teacher and facilitator, and I'm going to walk you through Lesson 3 of the 8.4 unit Earth in Space. What I find really powerful about this lesson is that students are doing a lot of data analysis and not only just noticing patterns or trends, but then applying those patterns to revise a model that we create at the end of the lesson. So, how did we get here? In the previous lesson, we figured out that the North Star does not move because the Earth's axis is pointed towards it, and other objects appear to move in the sky in predictable patterns. We created a model, but we're wondering, can we explain yearly patterns in addition to those daily patterns that happen? So let's take a look at this lesson. It is going to involve problematizing and an investigation. It is a lengthier lesson for 3 days. It'll take about 60 to 90 minutes of prep. There is a hands-on investigation. Students will be looking at a video or manipulating a simulation and then working with a 3D model. It will be beneficial to have devices for each student or each group of students. And there's a stellarium orientation video for you to look at to better understand how to use this software. When we break down this lesson into 3 parts, you'll see that in the first chunk of day 1, students figure out that the angle of the sun and the hours of sunlight increase from January to June and then decrease from June to December. And then we wonder, has that always been the case? And students look at data over thousands of years and find out that yes, this pattern still holds true. We then create a physical model, and we realize that data we collected in the first chunk doesn't match what's happening with the 3D model we created on day 2 in the second chunk. What are we missing? And that motivates us into the third day, where students then are physically revising the model to see if they can change the tilt of the Earth's axis so that our data from day 1 matches what's happening in our 3D model on day 3. What we will figure out in this lesson. In the first day, students will figure out that there are changes that happen to the length of day and the angle of elevation of the sun, and that this pattern happens repetitively over very, very long periods of time. On day 3, students will figure out that the Earth's axis is tilted and pointed at the North Star, which is called Polaris, and that this tilt is what's causing those changes we observed in the amount of daylight and solar elevation over the course of a year. Let's break down some key moments in this lesson. For part 3, students observe the sun with the Stellarium software. With our student iPads, I've run into some problems with running the Stellarium software, so we use the YouTube videos that are provided. Students are able to get all the necessary observations from there. There is an orientation video to help you understand how to measure elevation of sun. I recommend that if you don't have students watch it, you watch it and then share out that information to students. That way they know how to collect that data, because specific observations are going to be very, very useful, as students will be chunking parts of the year. We don't want them just say, oh, the sun is kind of high in the sky, because they will need to share out that data to their lab partners who looked at other parts of the year and then make sense of what's happening to the sun January to December. Drawing the path of the sun can be helpful so that students can understand what that angle of elevation means and kind of see what the sun is doing over the course of a year. In part 4, students are looking at those solar patterns over thousands of years, seeing if it stays the same or not. I use just the first website to get all of the data. I find that sometimes students can get overwhelmed looking at both of the websites. There are a lot of numbers, and if they aren't familiar with solar elevation, changing the different dates and things, it can get a little overwhelming for them. I take a screenshot of that first website and color code where they're supposed to look for different data points. That way they don't get lost in all the numbers that are on the screen. They can focus just on the data we want to collect and then compare within their group. Something that I have noticed that when students get to the part where they're comparing what happened to those solar patterns over the course of 500 years, 1,000 years, they are looking to see like, oh, it's the amount of sunlight is increasing, and pointing out we're looking at those annual patterns. We're not looking at what's happening just month to month. We want to know the pattern you see month to month. Is that the same over 500 years, 1,000 years, kind of crisscross and mix up those two things? So having that conversation to point out, is the pattern of sunlight staying the same over 500 years, 1,000 years, not what is the pattern over the course of 1 year. Part 11, when students are revising the model of the Earth-Sun system, talking through what is the point of that fabric tape, what is that representing, and making sure that students really understand what the parts of this model represent before you turn them loose to work will really help them make the connection between that day one data they collected and what they're doing with that 3D model. I've also found that students have struggled with the rubber band representing the path of the observer. When they move the push pins, the rubber band gets moved, they forget where it is. So I've taken to just drawing a line with a permanent marker on the styrofoam, and then that way it stays put and no one has to try and figure out exactly where that rubber band was before. And definitely lots of conversations about safety and not playing with the light bulbs, and making sure when you're carrying things back after the light bulb has been on, you don't let the styrofoam ball touch the light bulb because it will melt. After figuring out that Earth's axis is tilted, where do we go next? We want to consider how that tilt affects our lives on Earth. Now let's break down some material management tips and tricks. When you are working with that 3D model and you are building them for the first time, I recommend using a drill so that way you can get the straw and that wire through the styrofoam ball easily. The wire is very bendable, which is intentional, so students can explore the different tilts of the axis, but makes it a little challenging to set up for the very first time. I'm also planning out darkening the room. The darker, the better. And so I have had to cover my windows with black butcher paper, or borrowed some trifolds that students used as projects in other classes to kind of help block sunlight coming in. And then outlet access, making sure that you don't blow any fuses and things like that when you have all these light bulbs plugged in. Another option is to use this as stations, so you have fewer light bulbs plugged in. For your word wall, we do earn quite a few words in this lesson. There are several building understanding conversations where we figure out elevation, Polaris, daily, yearly, and solar. These are just suggestions of definitions. You want to write them in the words that your students pick. These are just examples of what my students have come up with. And you will encounter the word horizon. And then just having that conversation, that's where the sky meets land or water, especially helpful when understanding elevation. Poster management. You will be referencing the patterns in the sky poster from lesson 1. And then in this lesson, you will be ending by making a poster where students are recording activities that happen when the amount of sunlight changes. That will help you navigate to the next lesson. And then materials that we create that you'll save for future lessons, changes in sunlight and angle over the course of 1 year. I ended up referencing this poster so many times. It was so useful, especially when students were thinking back in the assessment that is coming at the end of this lesson set. Thank you for joining me as we explored Lesson 3. I hope your students enjoy analyzing the data and applying it to their 3D models to figure out that Earth's axis is slightly tilted, which causes those annual solar patterns. And I look forward to seeing you in Lesson 4.